Alright, this is a video for assignment 12, geometry. As you're watching these videos, you don't have to watch every second of this video. I would flip through it and check your answers, and if you miss a problem, then go back and watch how I worked it out. But you don't have to watch every second. First thing I'm going to do is I'm going to write this up top here, SOHCAHTOA. Remember that phrase, SOHCAHTOA. So, sine is opposite over hypotenuse. Cosine is adjacent leg over hypotenuse. And tangent is the opposite leg over the adjacent leg. I'm going to label each triangle here. Go sort of quickly. This is your opposite leg. Your hypotenuse is across from your right angle. This would be your adjacent leg then. The other thing I'm going to label here, across from big B, we'll put little b in there so that when we're finding these different parts, we know which part we just found. And across from big C is little c. Across from big A would be little a, but we already know it. Now I'm going to first thing, probably the easiest thing to do on this one is find angle B first. When we're solving the triangles, we're finding all the missing parts. So if I find angle B first, I just take 51 plus 90. That gives me 141. Subtract that from 180. That gives me 39. So measure of angle B is 39 degrees. That's one of our answers. Next, it doesn't matter really what you find. I'm going to find little b. So that's the adjacent leg. I also need to use this opposite leg because that's the number I know. I don't want to use the hypotenuse right now. So these are the two I care about for the moment. Opposite and adjacent. Opposite and adjacent is the TOA part. So that's tangent. So I set up my equation tangent of our angle, which is 51 equals the opposite, 14 over the adjacent, which is B. You grab your calculator, find the tangent of 51. You end up with 1.2349. Remember, go out 4 places, put a 1 underneath that, 14 over B. Again, as you do a whole bunch of these problems, you probably don't have to do every step here. You can figure out the pattern, but I'm going to do the steps for some of them here. So that's times B. We cross multiply the other way and we get 14. Then you're going to divide both sides by 1.2349. 1.2349. These cancel out and you're left with B. So we divide this and that's going to be our answer for little b. So I got 14 divided by 1.2349 hit equals, I get 11.3. So little b here is 11.3. Several different ways you could find little c. I'm going to use Pythagorean's theorem to find it. A squared plus b squared equals c squared. We know the two legs, those are our A's and B's, so I'm going to put 14 squared plus 11.3 squared equals C squared. All of this, you can stick it right into your calculator. You just put in 14 squared plus 11.3 squared, and you end up with 323.69 equals C squared. Take the square root of both sides. Over here, the square root and the little 2 cancel out. And then you just got to find the square root of 323.69. Second square root, 323.69. And we end up with 17.99. We'll round that up to 18.0. So we found all 3 missing parts in the triangle. Again, there's several different ways you could do it. On number 2, I'm going to do a couple of them a little different. We're dealing with this angle. That's your opposite leg. And that's also little a because it's across from big A. Your hypotenuse is over here, and that's also little c. And then this other side over here would be your adjacent, and it would be little b, but we've already got it, so we really don't have to have that in there. I could find angle B first. That'd probably be the easiest thing, but I'm going to save that and do it different this time. So instead of finding angle B, I'm actually going to find, let's find little a first. So we want to use the opposite and adjacent. Well, that's going to be the tangent of our angle, which is 37 degrees, equals the opposite, that's little a, over the adjacent, which is 12. We grab our calculator and we punch in tangent 37, and I end up with 0.7536. Put a 1 under that. A over 12. This is one of the nice ones because when we cross multiply, we get 1 times a. Well, that's just a. So when we cross multiply this way, it's just going to give us our answer. So we just take 12 times 0.7536, and we end up with about 9.0. So little a right here is about 9.0. To find big B, I can use these two, opposite and adjacent. Actually, I need to switch it because now I want to find angle B here. So this, instead of being adjacent, for angle B, this is going to be the opposite leg. And this one over here is going to be the adjacent leg, because we're dealing with angle B now, if that's what we're trying to find. But it's still tangent because it's opposite and adjacent. So it's the tangent of angle B equals the opposite leg, which is 12, over the adjacent leg, which is 9.0. And then our calculator will do all our work for us here. We hit second. Let me clear this off. We hit second, tangent. Remember, when you hit that, it comes up on your calculator, tangent -1. Tells the calculator you're finding an angle instead of just finding the sine, cosine, or tangent. So we're actually, it's going to give us an angle answer. 12 divided by 9.0, close the parenthesis, hit equals, and I get 53.13. We'll round that off to about 53 degrees since we're looking for an angle. We could have found that again by saying 37 plus 90 and subtracting from 180. It's going to give you the same answer. I just wanted to show you a different way to do it there. The third one, the other side here, we'll just stick with that since we've already got this labeled opposite and adjacent. And we could use trig. We could use Pythagorean's theorem. I'm going to use one of the trig ratios this time. I'm actually going to use this opposite leg and the hypotenuse. So opposite and hypotenuse, that's the sine. So the sine of our 53 degree angle, because this is the opposite for the 53 degree angle. So sine of 53 equals opposite leg, that's 12, over the hypotenuse, which is c. Grab your calculator and you hit sine 53. It comes up to be 0.7986. Put a 1 under that. 12 over c. We cross multiply, we get 0.7986 times c equals, cross multiply this way, you get 12. You're going to divide both sides by 0.7986. Remember, when you're dividing by that number like 0.7986, then your number is going to get bigger. 12 divided by 0.7986, and we get 15.0. The other thing that you could have done on this one, if you recognized it, this triangle actually fit into that 3, 4, 5 family. This 3 went along with this. It was 3 times 3. This was the 4 part, which was 4 times 3. So that means this side over here should have been the 5 part, and it had been 5 times 3. Well, 5 times 3 is 15, and that's about what we got. In between the two, this is not an angle of depression. Angle of depression has to start on that straight out horizontal. But what we do know is this angle here, or the angle of depression from here to here, is exactly the same as this angle. So we could use this angle down here as our 55 and 28. So we could put 55 in there and 28 in here. So we could do it either way and just use the two separate triangles. I have the black triangle there. Then you also have this red triangle. And you're just going to find two different things here. So if I separate these two triangles, because it's confusing the heck out of me, if I separate it and I got this black triangle, this is 55 degrees, this is 10 kilometers, this is a right angle. We want to find this distance here. And then for the other triangle, this is 28 degrees. The angle, what I'm saying there is that angle of depression, if somebody's up here in this plane, that angle of depression for them looking at town A here is the same as if there was a person standing there in town A looking up. It'd be the same as their angle of elevation, because those are alternate interior angles. So it's just one way we could do it. We could have done it this way, just separate off the two triangles up here and find that distance. It's the same thing, just two different ways to deal with this problem. That's 28. We know this is 10 kilometers. We're looking for this distance. We'll call it Y. These two are basically going to be the same problem done over and over again, so I'm just going to write them out and do them both. That's your opposite leg. That's your hypotenuse. We really don't care about the hypotenuse this time. This is your adjacent. So we want opposite and adjacent. That's tangent. So we're going to do the tangent of 55 equals opposite over adjacent. Then for the other one, I'm just going to do these both at the same time. That's your opposite leg. This is your adjacent. That's your hypotenuse. We really don't care about the hypotenuse this time. It's going to be the tangent. Instead of a 55 degree angle, it's going to be a 28 degree angle. Equals 10 over Y. Notice they're basically the same problem, just changing the angles. So I'm going to do them just both at the same time here. So tangent 55, we get 1.4281 equals 10 over X. Put a 1 under that. I'm going to do the tangent of 28. On the other one over here, that's 0.5317. Put a 1 under that. Now, when we cross multiply, all we're going to end up doing is taking this 10 and dividing by this number. Over here, we're going to take 10 and divide by that number. So that's just going to give us X and Y, and I'm just going to do those instead of doing all the steps. So we take 10 and we're going to divide it by that. So 10 divided by 1.4281, and that gives me 7.0. And then over here we do 10 divided by 0.5317. That gives me 18.8. So this distance from here to B is 7.0. The distance from there to A is 18.8. We want to know how far apart they are, so we just subtract those two. So we just take 18.8 minus 7.0, and we end up with 11.8. So the answer to number 9 is those two cities are about 11.8 kilometers apart. Number 10 says a point 30 feet from the base of a tree. So I'm going to draw my tree here. We got some point out here 30 feet from the base of it. The angle formed with the ground looking to the top of the top measures 53 degrees. So going up to here, this angle of elevation is 53 degrees. Hopefully the tree makes a right angle with the ground. Find the height of the tree. So we're looking for X right here. Label our triangle. Opposite leg, hypotenuse, adjacent leg. The ones we care about this time are the adjacent and the opposite. So that's the tangent, the toe part. So tangent equals, or tangent of 53. That's our angle, equals opposite over adjacent. So X over 30. We grab our calculator. We do the tangent of 53. It's 1.327. Put a 1 under that. X over 30. When we cross multiply, we're just going to get X here. So when we cross multiply this other way, it's going to be our answer. So I'm just going to punch that into my calculator. 30 times 1.327. It was 270. Doesn't really matter. 270, and we get 39.81, or about 39.8 feet, but they said round to the nearest foot, so that's 39.8. Well, we're going to round that up to about 40 feet. Number 11 says an observation tower is 75 meters high. A support wire is attached to the tower 20 meters from the top. So we got our tower here, whatever it looks like. It's 75 meters tall. We got some wire that's hooked to it, supporting it. But it's 20 meters from the top. If the support wire and the ground form an angle 46 degrees, so this angle down here is 46 degrees, how long is the wire to the nearest tenth? So we want that distance right there. So this is going to be our opposite. That's our hypotenuse. The adjacent we really don't care about this time. On this one, you might want to redraw this, because we're not doing the whole 75 here on this opposite side. We want to subtract 20 off that because the wire attaches 20 feet or 20 meters from the top, so that's only 55. This angle's 46, and we're looking for this. So we're dealing with the hypotenuse and the opposite. So we're dealing with these two. Hypotenuse and opposite, that's the sine. So we do the sine of our angle, which is 46, equals the opposite, which is 55, over the hypotenuse, which is X. We grab our calculator and we put in sine 46, get that decimal, 7193, put a 1 under that. 55 over X, we cross multiply, we get 0.7193X equals 55. Then we're going to divide both sides by that 0.7193, and that's going to tell us our answer. So 55 divided by 0.7193, we end up with 76.5. So it has to be about 76.5 meters long, the guy wire does. Number 12, an observation tower is 75 meters high. That's number 11. Number 12, at 10 a.m. a person observes a hot air balloon climbing vertically in the air from a point 300 meters away from the launch pad. For the balloon, the angle of elevation to the top of the balloon is 25 degrees. So we got our balloon. This person down here is looking at it. They're 300 feet from the launch pad, which is right here. And it says the angle of elevation is 25 degrees. So the angle to the top of the balloon there, angle of elevation is 25 degrees. So we're probably going to be figuring out how high up the balloon is. Then it says at 10:02 the person observes the angle of elevation to the balloon to now be 60 degrees. So we got the balloon up here still. They're still 300 feet from it. They're looking up the top of the balloon, and now their angle here is 60 degrees. We'll call that Y. What is the change in altitude? So we're going to figure out how much did the altitude of the balloon change. So we do this. That's your opposite. That's your hypotenuse. This is your adjacent. It's going to be the same for both these, so I'm just going to do them both at the same time. We're dealing with this angle here. That's your opposite leg. It's right angle. That's your hypotenuse. This is your adjacent. We really don't care about the hypotenuse this time, so we're dealing with adjacent and opposite. SOHCAHTOA, that's the TOA part. So we're going to do the tangent of our angle, which is 25, equals opposite over adjacent, so x over 300. For this one over here, it's going to be the tangent of 60 degrees equals opposite over adjacent, which is y over 300. When we get our two answers, we're going to subtract them to see how much higher or lower the balloon went. So we've got, grab our calculator, and I'm going to try to do both these at the same time. Quicken this up. Tangent of 25, so tangent 25 equals 0.4663 over 1, x over 300. We do the other side. Tangent of 60 equals 1.7320 over 1, y over 300. When we cross multiply here, we're just going to get 1 times x. So our answer over here for x is just going to be whatever 300 times that decimal is. So 300 times 0.4663, and I end up with about 139.9. Do the same thing on the other side. We're just going to get y that way. So 300 times 1.7320. I get 519.6. Now, so 2 minutes later, the balloon was 519.6 feet off the ground. It started off 139.9 feet off the ground. So all I'm going to do with those two is subtract them. 519.6 minus 139.9 minus 139.9, and I end up with 379.7. What did it say? Did it say how to round it? Nearest meter. So 380. So the balloon went up about 380 meters.